Okay, so when you think of Mercury, what comes to mind? Probably a scorched, dusty rock, right? Baking right next to the sun. And yeah, you're not wrong. But what if I told you that same fiery world is also hiding billions of tons of ice? I know it sounds completely impossible. It's a paradox that just doesn't seem to add up. And today, we're going to solve it. I mean, just look at these numbers. At its equator, Mercury can get up to a blistering 430 degrees Celsius. That's hot enough to melt lead. But then, in some craters near its poles, the temperature plummets to a bone-chilling -170. That's not just a difference, that's a chasm. And that is the core mystery we're tackling today. How can a world of such extreme fire also be a world of extreme ice? So let's put on our detective hats for this one. This is a genuine cosmic mystery. Our mission, if you choose to accept it, is to solve this fire and ice paradox. We're going to figure out exactly how the sun's closest neighbor is secretly hoarding these massive reserves of frozen water. So how is this even possible? Well, the answer isn't some kind of space magic. It's actually a perfect cosmic loophole. It all comes down to two very specific key factors. A really unique combination of physics and planetary geometry that allows ice to survive in a place it honestly has no business being. All right, the first piece of the puzzle, it's all about the way Mercury stands. Seriously, it's all about its geometry. This unique posture creates these little pockets of eternal, freezing darkness right next to land that's literally being cooked by the sun. To really get this, we need to quickly talk about something called axial tilt. Now, it sounds technical, but it's super simple. It's just the angle a planet is tilted on its axis while it spins. You know, Earth's tilt, that's the entire reason we have seasons. It's because different parts of the planet lean towards or away from the sun as we go around it. Now, Earth has a pretty significant tilt, right? About 23.5 degrees. But Mercury, get this, it stands almost perfectly straight up and down. Its tilt is less than 1 degree. It might seem like a tiny little detail, but it changes absolutely everything. It means that if you were standing at Mercury's poles, the sun would never climb high into the sky. It would just forever skim along the horizon. And here's where it gets really interesting. Because the sun is always so low on the horizon, the floors of those deep craters near the poles, well, they never ever see direct sunlight. They're cast in a permanent shadow. We're talking about pockets of darkness that might not have seen a single ray of sun for billions of years. Scientists have a great name for them, permanently shadowed regions. But just being in the dark isn't quite enough. That brings us to the second part of this cosmic loophole, something scientists call a cold trap. See, Mercury has basically no atmosphere to speak of, so there's nothing to move heat around. This means that while the rim of a crater can be scorching hot, the floor, deep in that shadow, gets unbelievably cold. So cold that any little bit of water vapor that wanders in freezes on the spot, and it's trapped there forever. Okay, so the theory holds up, right? You've got these perfectly dark, perfectly cold little pockets where ice could exist. But that's just a theory. How did we actually prove the ice was really there? Well, now we get to the evidence. Let's see how the case for ice became absolutely watertight. You know, the first clues actually started trickling in back in the 1990s. The huge Arecibo radio telescope, looking all the way from Earth, spotted these weirdly bright patches at Mercury's poles. And that brightness, it looked a lot like reflections from ice, but it was just a hint, a clue. It wasn't until 2011, when NASA's Messenger spacecraft finally got there and went into orbit, that we could get a good close look and really turn that suspicion into solid proof. So the big question is, how did Messenger nail it down? Well, this is the best part. It didn't just rely on one piece of data. No, it built an absolutely irrefutable case using 3 separate, completely independent lines of evidence. It was a slam dunk. First up, its neutron spectrometer sniffed out huge concentrations of hydrogen, the H in H2O, right in the exact same spots where those bright radar patches were. Check! Then, its laser altimeter measured the reflectivity of the surface. And guess what? It found super bright, highly reflective surfaces right inside the coldest shadows. That's exactly what you'd expect from exposed ice. Check! But then, it found something else. Something unexpected. These dark, less reflective patches in slightly warmer craters. Now that was a new twist. So, okay, the ice is real. It's there. Case closed on that front. But that just opens up a whole new, obvious question. On a planet born in fire, this close to the sun, where on Earth or Mercury did all this water even come from? Well, it turns out the answer is basically a cosmic delivery service. The leading theory is that this water isn't native to Mercury at all. It didn't form there. Instead, it was delivered parcel by parcel over billions of years by comets and water-rich asteroids slamming into the planet. So here's how that process probably worked. Imagine a water-rich comet or asteroid smacks into Mercury. Boom. The impact instantly vaporizes the water, sending H2O molecules flying everywhere. They start hopping across the surface in these big, arcing paths. Now, most of them just escape back into space. But every now and then, a few lucky molecules happen to land in one of those super cold, permanently shadowed craters at the poles. The second they hit the ground, they freeze solid, and they're stuck. Now just repeat that process for, a few billion years, and you end up building massive ice deposits. And remember those mysterious dark patches Messenger spotted? This is where they come back into the story. Scientists now think they're a layer of organic compounds. We're talking about complex carbon-based molecules, basically the chemical building blocks of life. And this dark stuff was likely delivered by the very same comets and asteroids that brought the water. It forms a kind of dark blanket over the ice, insulating it and protecting it from being lost to space. So what's the big deal? This is way more than just a cool fun fact about a weird planet. Finding both ice and organic materials there has some really profound implications. You have to think of these polar craters as perfect deep freeze time capsules. And I mean massive time capsules. The sheer scale of this is just staggering. We're talking about an estimated 100 trillion to 1 quadrillion kilograms of ice at just the North Pole. To put that in perspective, that's more than enough water to fill a huge lake, like one of the Great Lakes here on Earth. So at the end of the day, why does any of this matter? Well, for a few huge reasons. First, it just completely rewrites the rules on where we can expect to find water in a solar system. Second, this ice and the organics mixed in with it, it's a pristine chemical record, a time capsule preserving the exact kinds of building blocks for life that were delivered to all the inner planets, including a very young Earth. And looking way ahead, this ice could be an incredible resource for future human exploration. It's water to drink, oxygen to breathe, and even rocket fuel. Ultimately, what the story of Mercury's ice really shows us is that even the most unlikely, hostile places can hold the most incredible secrets. It really makes you wonder, doesn't it, as we keep exploring, what other impossible truths are hiding out there in the darkest, coldest corners of our solar system, just waiting for us to find them.